First off, thanks for coming out. I appreciate you coming out, appreciate the opportunity. Today, we're going to be talking about files, specifically file visibility, detection, and response. And with the use of an open source tool, you can just get better at that. Today's talk is going to be broken up into three parts. The first is going to be the problem, right? So the chaos, part of the title. The second part is going to be the tool, so Strelka, going to help with detection and visibility. And the third part, a relatively recent update addition to Strelka, which is a visualization component, a UI. And that's pretty much the reason why I wanted to come here today. First about me, though, my name is Paul Huddlemeyer. I've been at Target for about 8 years now. I've recently started a role as a director of engineering doing threat hunting, but previously I was on threat detection, engineering, building tools, building solutions, automation, stuff like that. One of my things I had to do was work on the open source. So Strelka and Strelka UI, those are two tools. Those are the ones we'll be working on today. That was my goal. So first section, the problem, chaos. Do you know what files are on your network? So we'll start with a question, a pretty basic question first. How many files exist on or move around your network each day? Okay, you have hosts, emails, servers, cloud, et cetera, right? And the answer is you don't know that answer. Maybe you know a little bit about it, but that's something you just have to make assumptions about, right? But if you go a layer deeper, right, do you know what some of those files are? On the host, right, you're going to see things like executables and shortcuts, et cetera, right? On your network sensors, you're going to see scripts and certificates, right? And I guess more specifically about emails, you're going to see bodies, images, attachments, right? Emails are just parts, right? Multiple parts. But like these don't really exist in those boundaries, right? They exist across boundaries. And there's way more than this too, right? But let's assume that you do have some visibility, right? Let's assume that you can get some of these files. Do you know what they contain? We're going to take a look at Word documents right now. I'm going to break that up into two parts, metadata and content. So metadata describes a file. Okay, so for Word documents, it's going to be the author, created date, comments, right? Stuff that helps describe the actual file. And the content is going to be what you perceive the content of a Word document be, right? Scripts, tables, formulas. It's the actual words. And if we take a look at executable files, right, we can do the same kind of exercise, right? You have metadata, such as the company name, file version description. These are things applied to executables when they're compiled. And then you have the content, right? When you actually run the executable, what's running, right? The libraries, the functions, the resources, sections, et cetera. So why should we care about this data? Why should we care about files, right? If you have better visibility on those files, right? And you have the context, you know what the metadata and the content should be, you're gonna have better detection response, right? And that's the goal. So let's take a look at a really quick example of how this could be used, right? Word documents containing macros, right? A lot of us are probably familiar with that. And if we take the original file, which is just a Word document, and if we assume there's an embedded file in it, a VBA file, so your macro, we might be able to assume that there might be some risk signatures in there, right? If the script auto runs when you open the document, right? If there's operating system references in there, if there's encoded commands like PowerShell, right? None of these are bad by themselves, but you group them together, they start to make a pattern, right? You might be able to create detection off of risk signatures or just concepts, right? So if you take that approach, right, you can probably answer other questions as well. Like if I have images, can I use optical character recognition to maybe identify keywords of interest, right? So a phishing email, I have some common keywords that I typically see in my phishing emails. Can I use OCR and images to maybe pull those out? Compressed files, so zips or ISOs, right? What if there's only a couple of files inside of an ISO? That's kind of strange, not typically what an ISO is for. That's a common threat vector. Just going a little more specific, Microsoft shortcut files, right? Something that threat actors have used relatively recently, right, is putting shortcut files inside of an ISO by itself, right? That's like obfuscation. Can we see that shortcut file inside of an ISO? And then maybe something more like generic. Can I look at the compile times for executables, right? Can I look at section hashes? Maybe if you get your entire network of compile times, can you maybe stack them differently so you can see the outliers? Okay, so what was our actual solution for collecting and analyzing these files then, right? You have all these different spots, you have millions of files. What's our solution? Second part, that's the tool, that's Strelka. So Strelka it was created in 2019 by Josh Liberty. He worked at Target at the time. And the goal of Strelka is file identification, extraction, and static analysis. So the goal ultimately is to improve visibility, detection, and IR, right? All three of those pillars. A couple highlights for Strelka. It has over 120 different file types that it supports. And these are your common file types, your executables, archives, documents, et cetera. And also the commonly exploited ones, right? So maybe not OneNote, but OneNote had its time about a year ago. Strelka is also recursive. So what that means is if I give it a zip, it's going to tell you about that zip, but it's going to tell you about the files inside that zip as well. It's going to tell you about the Word document, but it's going to tell you about the images in that Word document too. It's fast, scalable. So at Target, we scan about 350 million files per day with Strelka. They scan within 1/10 of a second, 100th of a second, et cetera. And the support and growth, it's been around for 5 years, and Target pretty much deploys what is on the open source internally. We've had great success detecting some weird stuff. So really quickly, how does Strelka work at a high level? So there's a client that can sit on your endpoints, on your networks, et cetera, or just yourself. You can just take the client. And you give it a pattern of files, paths, whatever it may be. And it's going to go ahead and send those files up to the front end, pretty much for load balancing. And then it goes to, I guess, the biggest part of the system, which is the worker, the back end. This is where it does its file identification, does its analysis, it wraps it up and sends it back to you. It's going to be sent back to you, and we'll take a look at what sending back to you means, because it might be kind of ugly if you want to look at it yourself. So let's take a look at an example. I don't really want to go into the technical aspect of Strelka for the rest of the day, but we're going to look at an example for 2018, and you might be thinking that's pretty old, right? The reason why I want to use this example is this is a sample that Josh Liberty used in his presentation in 2019 at B-Sides. I'm bringing this up because the UI component later, we're going to revisit it and show that how it's helpful, in a current state rather than a couple years ago. Anyway, I do recommend you check that talk out if you care more, if you want to look into just the philosophy behind Strelka. So this sample, it's a malicious macro resume lore. Okay, so when you open this resume, it's going to go ahead and run a macro. It's going to put a launch agent on your Mac, and it's going to run a startup script for a Python startup script, right? One thing that is interesting about this file is it has a lot of obfuscation using base64. Not typically uncommon, maybe a little less common in 2018, I don't know. But it's a characteristic, right? It's not bad, but like, why is it there? Right? So those characteristics, they might add up if you have that content. So what Strelka can do with this file, you give it this file, it's going to be able to return file metadata. So VBA functions, strings, right? Yara matches, and more. And this is an example of a very, very truncated example of the Strelka output. First, we start with the file type. Strelka says, oh, I see an Office document, okay? And because I see an Office document, I'm going to run my zip analyzer on it because Office documents are compressed files. It was able to pull out 18 files, so images, script, whatever it may be. You can see at the bottom, maybe, if it's not too tiny, Visual Basic extraction. So you can see references to base64, you can see references to launch agent strings, et cetera. And you can also see a URL. It collects URLs, IPs, domains. These are not saying this is bad, right? It's just giving you the content, and you have to make the decision yourself. I did really want to highlight Yara as well. So we see a couple matches here, about 10. They all kind of say the same thing, right? It's an Office document. It has a macro. right? And that's good, right? Because it's not bad, right? Yara is used for detection a lot, but it's used for characterizing content as well. So just by looking at this Yara, I don't need to look at anything else. I can just assume that we got an Office document with a macro. And I want to highlight here, right? You see that number, maybe 35,000 rules loaded, right? Those are Yara rules loaded. So we have 35,000 Yara rules running in 300ths of a second and matching against this file. So multiply that out by 350 million files. That's a lot of insight into your files, right? Just Yara alone. All right, a more recent example. So PDF lore from last year. Once you open that PDF up, it's going to go out and get a window shortcut. It's going to bring that down. You open up that shortcut, goes out and gets its final C2 payload. So with Strelka, I want to highlight, right, this is a static analysis tool. Okay, so Strelka gets that PDF, and it's going to give you the context, the images, the title, stuff like that, links. But it's not giving you that shortcut. And it's not giving you the last C2 payload, right? Because it's not going out and doing that work. Security, speed, right? There's a reason behind it, but like there are limitations to it. And that's how it can succeed at going so quickly and telling you about the file. So if we look at the output or truncated output, right? Strelka says, I got a PDF. Here's some PDF details, like at the creation date, the author, et cetera. You can see the link where the shortcut probably lives or lived, right? So you will not be seeing that content. You won't be seeing the shortcut analysis in Strelka, unless, of course, someone did run it and then Strelka saw that data as well. That would be bad. But static analysis. So then you might be thinking, well, how do I use this for detection, right? Well, here's a couple examples of how we've used Strelka for detection, right? So you can use it for basic Yara signatures, like I know this is bad, therefore detect, right? But in this example, we have two Yara matches, right? Office documents with macros and base64 encoded URLs, right? We just talked about that. But if you add those signatures together, your confidence rating goes up. That's weird, right? It has a macro, and why did someone make a macro with base64 in it? Not bad, right? But maybe something to look into. OCR, right? I mentioned that as well. You can probably look for phishing emails, toad emails, et cetera. You know a series of keywords, you can find them if the image pulls out the text. Compressed images, so ISOs, right? If you want to pull out hidden directories from your ISOs, if you want to say, I want to see how many files are in this ISO, if there's less than 10, right? That's weird. Why is there an ISO that's so small, right? It has so few files in it. Executable build paths, right? You just want to look for weird PDB paths, pulls them out. Strelka has a batch scanner, a JavaScript scanner, Visual Basic scanner. So we're pulling out strings from all those different scripts. So if you have some indicators you want to look for, you can go ahead and look for those strings. And then again, like IOCs, just basic IOC matching, right? That's kind of boring sometimes, right? But when you have 350 million files going by, maybe that's not a bad thing to have a list that just matches against URLs and IPs, et cetera, that files come across. So this seemed useful, right? But it's hard to analyze, right? It's hard to look at, right? I showed you JSON, right? What are you going to do with that? You're probably not going to do anything with it, right? Maybe you'll put it in a SIM, you put it in a logger. It's good for pattern matching, but like, what if you just wanted to look at the file itself? Again, the sample I gave you was truncated. How truncated? Pretty truncated. So this is what that file looks like when it's not truncated. As you can see, you're not looking at that. You're not scrolling through that file, right? Maybe you'll use JQ, maybe you know what to look for. You'll do a Control F and look for that string, but like at a large scale, you're not going to be doing that. This doesn't tell you anything. It tells the system what the file is. And that's going to bring us to the analysis, right? So visualizing the content. So we already kind of went over why this is kind of hard to look at, the JSON, right? It's large, right? We've seen 1 megabyte, 30 megabyte responses, right? That's a lot of JSON, right? You're not going to be looking at it yourself, even if like your text editor can load it up, right? It's a lot. Also, it's recursive, right? So I mentioned that Strelka is recursive. There's parent-child relationships. So your Office document, right? It's a zip file. It has JPEGs in it. It has scripts in it. You're not looking at that in a JSON blob, right? You're not going to be able to get that context. What if you just want to know what a file's profile looks like? So then ultimately the goal, right, was to turn this, which again, hard to look at, into something a little bit more friendly. Still kind of hard, right? Like there's still a lot going on here, but the more time you spend in it, right, you can filter down, right? Filtering. You can just observe what is this file, right? It abstracts all the file content out, and then you can focus in where you want to. You could see I'm looking at these little boxes, right? We see one box on the left and then 3 boxes on the right. That box on the left is the initial file, and we'll get into that as well. And you see those lines going through those 3 boxes, right? Those are the children to that file. So right there you can see, oh, I have children files to this file. So it's helpful to understand a relationship, right? You can imagine it getting pretty ugly if you have a zip with zips in it, et cetera, right? So immediately you can say, I don't know anything about this file, but I know that there's content inside of this one file, right? And we'll go through some of the other content as well, right? You see that tab just opened up that has VirusTotal support, so you can quickly see, was this file seen on VirusTotal, et cetera. So the goal then, right, was to simplify. Simplify submission, simplify analysis, right? Simplify, just make it easier for you to just understand a rule, or sorry, a file. And also add additional like enrichment capabilities, filtering, et cetera. So a couple of highlights then, right? It's file submission is a lot easier. It's easy, intuitive. You can drag and drop files in, and it'll scan it and it'll give you a response in a second or two, right? You can zip up files. There's pass-through support. You can encrypt it. A little safer that way, right? Has API support, so you can send files from outside of just the UI, right? Data visualization, we just saw the screenshot. There's custom views, context-specific views based on the file you're looking at, and file relationships too. Submission enrichment, right? I mentioned VirusTotal. If you have a premium VT key, you'll be able to analyze those files as you submit them. It's going to tell you what the response, the hits are for those files. And filtering, right? So you submit files into it. You're going to be able to filter and say, hey, show me all files that this person submitted, or show me all files with this tag, et cetera. Right, so the goal, right, rather than you parsing a logger, right, looking in your SIM or just looking at the JSON data, right, you can observe, right? You can sit there and you can observe what is this file. So just taking another step back, that's just raw JSON on the left, just a different way to look at it. And then that's the Strelka UI view. Right, so just to emphasize, we have that little red image on the left, right? That's, can't really see it there, but it's a PDF image, right? So you can quickly say, I have PDFs, okay? And on the right, there's those 2 blue images. Those are little just image icons, right? Implying I have an image. There's references to the MIME type. There's references to IOCs pulled out, right? It's bubbling up the stuff that I hope you're interested in up to the top, so you don't have to like drill down into the data. Here's another example. This is a file that has you submitted one file, has 29 children under it. You're not going to be able to read that in JSON. You probably won't even be able to see the relationships inside of a SIM. So what we give here is like, okay, well, I submitted what looks to be like a Word document, right? And there's 16 XML files in this Word document. I don't want to look at the XML files. So you can quickly filter, right? You can click on the VB file, the little red icon, and it's going to get rid of everything else and just show you the VB files. So a really quick way to jump to probably what you care about. It's going to give you a full file listing of all the files that were submitted, or sorry, the file that was submitted plus all the files that were extracted. Indicator listings, so any URLs, domains, et cetera, that were pulled out. It's going to show you those and allow you to filter. So if you see a weird URL, you can just get rid of everything else and just look at that one file. File type filtering, we just went over that, and YARA filtering. So which files match which YARAs, and then also a little bit of like organization. YARA is, it's not a standard way to do metadata, but we tried to organize it by maybe suspicious and just like classifiers, right? Characteristics. Okay, so let's take a step back to that 2018 sample and see how the Strelka UI can help. Again, this is what the output used to look like. Still does, but what it looked like before the UI. And this is what it looks like in the UI. Still a lot, right? It's like a web. It's still pretty hard, but the value here, right, is you can spend 10 seconds in here and just scroll, filter, find the file you care about, open it up, and like looking at that, you can see some strings. I think this one's looking at the base 64 strings. You can just see the highlights of the IOCs, the file types, filter, your virus. There's a lot of data here, right? It's not necessarily new data that's not in the JSON, but it's just packaged in a way that makes it a little bit more digestible. Let's take a look at one more example. Form book phishing. We have an email with an attachment on it, a RAR file, okay? So if you open up this RAR file, you're going to get an executable. You run the executable, it's going to steal your credentials. This is what the Strelka output looks like. There's a pattern here, right? It's ugly. It's hard to look at. This is what it looks like in the UI. You can quickly see there's 3 files here, okay? The one on the left is our email that was submitted. You're going to get specific to that email, you're going to get email specific data, right? So subject, sender, et cetera. The second file is linked to with the child, that's the RAR. You see 1 of 1, that implies we've extracted 1 file that we saw inside that is RAR, and then in that file we have an executable. And we get executable information if you click on it, such as section hashes, signatures, et cetera. So a couple added benefits to using Strelka UI. It's just quicker and safer static analysis, okay? So I already mentioned you can upload encrypted samples. So if you upload a sample, you can password protect it, give Strelka UI the password. It's going to know what to do with it. It's going to send it to Strelka, decrypt it, and tell you about that file. The amount of times people handle malware because they want to analyze it, even in a sandbox, kind of tricky. So you want to try to obfuscate that as much, which means also you can just submit straight from VirusTotal as well if you have a premium key. So just give the hash, instantiate Strelka with the VT key, and you don't have to touch the file at all. The second could help for threat intelligence, right? You can tag files in the UI. There's hot links as well. So if you submit a file, you're going to get a hot link. You can share that to other analysts, right? Hey, there's this weird file. Check it out. And they can look at the profile right away. And then third, right, if you have a SOAR, it might be interesting to maybe plug this in. You have a detection that says, hey, I got a weird file. I'm going to collect the file. Collects the file, sends it to the Strelka UI through the API. It's going to give you a link back. You put that in like the case notes before an analyst even starts working on it. They start working on that case. They can go straight into Strelka UI and just start to understand what the file is or what the files are, right? And that's a lot safer than them saying, I'm going to go pull the file from the host. I'm going to go ahead and bring it to my host, maybe throw it in a VM, whatever they will. Also has dark mode if you care about that. So how can I get started with Strelka? Strelka and Strelka UI are open source tools. I mentioned, right, I switched roles recently. So the lead on the project now is Sarah Kalupa. She works at Target as well. There's a quick start for Strelka. On the Strelka repo, this was created by Ryan O'Horo at Target as well. This is very helpful to just get you started with a local Strelka cluster. You know, it could be intimidating and be like, this is a tech stack, right? What do I do with it? But it does its best to get you started locally. You don't have to worry about anything else. It's going to give you some basic URL rules to use. It's going to give you a file to use so you can compare with the quick start itself to see if you're getting what you should be getting. And then it's giving the UI, right? So you can just go to a local host webpage, drag a file in, and look at it. So wrapping up here, visibility, right? Detection and response, we're always trying to increase that, make that, increase our confidence, right? We want to know what's on our network, right? We want to know what's on our network because then we can detect on it. And we want to know if we can look at files differently so we don't have to bring files down. So we don't have to like wonder, does an analyst have a malicious file on their host or something, right? So you don't have to worry about visibility as much. And if you can increase your confidence through detection, and you can maybe increase your efficiency in your file analysis response, right? you can actually focus on the actual problem, right, which is doing the analysis itself, closing out that case. That's a much nicer problem to have. Thank you.